Okay, we are back. We're doing Stats260, and we're looking at 8.4, Chapter 8, 8.4. So this time we're going to work with proportions, and because we're working proportions, we actually get to use z-scores again. So we started with z-scores, then we moved to t's, and then now we're going to go back to z's with proportions. There is a stipulation that if you take the sample size times the proportion, that has to be bigger than 5, bigger than or equal to 5. And if you take the sample size times the chances of it not happening, Q, and multiply, that also has to be greater than or equal to 5. So there is kind of a stipulation about sample size / probabilities of occurrence that we don't want like extreme ones. All right. So the standard distribution can be used to blank for proportions. That would be test hypotheses. So test hypotheses. Hypotheses. And then it says, what's the formula? So let's write down the formula. I have it typed out, but this is read P hat. That's the little symbol above the P is read P hat minus P over PQ over N. So in the same way that like X bar is an approximation, you know, that's the mean of a sample, P hat is the proportion of the given sample. So P hat. I had one student, a high school student many years ago that just loved this P hat thing. He made his whole t-shirt up with hats on top of letters. All right, so let's take a look at an example on page 7. An educator estimates that the dropout rate for seniors at high school in Ohio is 15%. Last year, 38 seniors from a random sample of 200 Ohio seniors withdrew. At a 5% significance level, is there evidence to reject the educator's claim? Well, I don't know. Let's see. So first, we're going to state our hypotheses. The null is P is equal to 0.15. Now, P stands for the proportion of the entire population. And so the alternative is not that. Right? B, we're going to do a pretty picture. And because it is not equal to, we're gonna, it's a two-tailed test. And we're back to Z scores, and the significance level was 5%. So alpha is 5%. So we want to look up the critical value there and the critical value there. That's going to be our Z-scores. Those are both going to be Z-scores, our cutoffs on the top end and the bottom end. So 5%, we bust out that chart. We look at two tails, 5%. And then we follow it all the way down to the bottom. So 1.96. So this is going to be a 1.96, and this is going to be a negative 1.96, all right? So there's our, if it falls into the shaded area, we'll reject the null and conclude the alternative. If it falls into the unshaded area, we'll conclude the null and fail to reject the null. Basically, that'll be our conclusion. All right, so let's have at it. Find the statistic. So we're going to use this to find our test statistic. So Z is equal to LP hat is going to be what happened. What happened there? P hat was 38 200ths, which is 0.19. Oh, so it's a little higher than the 15% rate. This sample showed a higher rate. We'll see if it's statistically significant. So we have P hat minus P, so 0.19 minus the 15, and you got it right there, P equals, over the square root of, and now all of this stuff is under the square root. So P, which is 0.15, times Q, let's see, well, if P is 15%, Q then is 1 minus 15%, which is 0.85, divided by 200. All right? So we end up with a z-score of 0.04 on the top and 0.02525 on the bottom. And when we divide that, we get 1.584. So is it enough to reject or fail to reject? So here, let's kind of section these off. Reject / fail to reject. All right, so let's see. We had to beat 1.96, and it looks like we fell short. This is our z-score is 1.584. So that is in the non-critical area. That is in all of this unshaded area is evidence for the null. So we fail to reject the null. That means this is our conclusion. We're concluding the null hypothesis. And then we'll do a quick little write-up for that. So we fail to reject the null at a 5% level. And then you restate, so, and conclude we restate this in words. That was our conclusion. So we conclude the high school senior dropout rate in Ohio is 15%. So in your conclusions, you have to kind of put it back in the context of the problem. This first line that I'm writing every time in your notes here, I expect to see that on the test also, but that's for the math people. That's for statisticians. They can stop reading after that. For the general population, though, I still want you to write out, oops, not here. Still write out and conclude the high school dropout rate in Ohio is 15%. So then we need context to the problem. All right? Okay, let's look at another one. So for this one, statistician read that 77% of the population opposes replacing $1 bills with $1 coins. To see if this is a valid claim, the statistician selected a random sample of 80 people and found that 55 were opposed to replacing $1 bills. At a 1% significance level, ooh, that's pretty stringent, test the claim that at least 77% of the population are opposed to change. All right? Okay. So let's take a look. First, our hypotheses. The null hypothesis is population, 77% of the population opposes. He thinks it's greater than that. So he did this as a hypothesis, but you're going to see why I laughed in a second here. So what does that mean? Let's draw a pretty picture. Alpha is 1%. We're looking at this. We look that up on our chart. 1%, one-tailed test. And now normally we said greater than or equal to because he said at least 77%. But in reality, we don't have a equal to in this. So if you gave me just P is greater than 0.77, that's fine in this context. Greater than or equal to is also okay. All right, so Z is equal to, we looked that up, one-tailed test all the way down to Z. That's 2.326. And you're going to see why I giggled when I saw his hypothesis. Let's find C, our test statistic. So Z is equal to, well, let's find P hat. Well, P hat, he surveyed 80 people, 55 of 80 were opposed. Well, that's 0.6875, which is less than this already. So his hypothesis was flawed from the word go. We'll still run the numbers here, but with that, 70% instead of 77%, it's not going to be greater. This isn't going to be evidence to produce greater. It's not going to breach that. It's going to be down on the below zero end. So, so his hypothesis was flawed to begin with here. 0.6875 minus 0.77 over the square root of 0.77. Now remember, that's P is 0.77, so Q is 1 minus 0.77. That's always based on P and Q, not P hat. All right, that's not a Q hat. So that is what, 0.23? And then divided by 80 people. So we end up with negative 0.0825 on the top. And 0.04705 on the bottom, which is negative 1.7534, which is clearly in the unshaded area. Oh, what a mess. Okay, so all of this is in the failed to reject region. This is the reject region. So we are going to fail to reject and conclude the null hypothesis. So D is either reject or fail to reject. So this was a flawed study from the word go, fail to reject. He should have maybe did better preliminary polling before he did this conclusion. So at the 1% significance level, we conclude the null hypothesis, which is 77% of the population opposes replacing the dollar. Okie dokie. So that's 8.4. Next video will be 8.5 and 8.6.